are you? We're gonna give everyone a chance to still come because I think we're gonna spend 1 minute on this. Hi, I'm Oleg. Very happy to see all of you here. It's a great honor to be presenting at Devoxx UK. How is the conference for you? All good? Whee! Okay. Let's try again. Let's start with a joke. What's the scariest plant in the jungle? It's a what joke. You need to say what. Okay, let's try again. What's the scariest plant in the jungle? Bamboo. Very good. All right. Let's just restart the timers, and we are good to go. All right. So, smooth sailing in the cloud-native storm. Welcome. We're going to talk about developer experience. We're going to talk about some cloud-native technologies. We're going to talk about testing your application and services. And this is a session that is mostly targeting application developers. And we'll see how it goes. Hopefully, there will be some new things that you're going to learn, and you can go and explore them at leisure, because clearly 50 minutes is not enough to actually teach anyone anything. It's mostly about sparking that interest. So consider this just entertainment. Right. So the problem with development nowadays is that the world is very complex, and the systems that we're building are also complex. And to solve problems of complexity, we as developers introduce tools and technologies, which only makes it more complex. And then somewhere down the line, maybe 10 years ago or something, we as the community figured out that we should be more productive. And the way to achieve that is to make our applications smaller so we can iterate on them faster and then build systems not as a giant monolith, but like as a collection of services. You can call them microservices if you will, but in general, it doesn't matter whether they're micro or like decent-sized services or like giant services. It's just larger systems consist of smaller parts that communicate via some things. And then there are also auxiliary technologies like data stores and message brokers and document stores and vector databases and other things which we need to use because we're building the systems. And sometimes it's our fault that we are building solutions that are hard to work with, right? Because there is no hero above us as developers, right? Whatever we do, whatever the problem we incur on ourselves is ours. Well, maybe the team before you, and you're coming there and you're like a much better developer, or maybe it's other people at the company because they are clearly inferior developers and they always make mistakes, sort of like drivers on the roads, right? Everyone who drives slower than you or drives faster than you are reckless, and slower than you are idiots, and only you drive at the proper speed at every given moment of time. It's sort of the same with development. It's never our fault, it's other developers' fault, but we need to fix it. Like, because there's no one else who is going to fix it, right? No product manager will actually, no offense to product managers, but they will not, if they go and change problems and fix problems in the code, they will become a developer, right? It's just less than a role, more of a thing. So as developers, we need to overcome that complexity that is inherently sort of production inspired, because we want to run our systems a certain way. There is also some problems in how we tackle the challenges in production, and we have tools for that. And those tools, there is a problem with those, that production technologies solve problems in production, and they're great at that, right? If you have experience with Kubernetes, for example, it's a great orchestrator for your production workloads. It's not so convenient to work with Kubernetes, for example, as an application developer, for a number of reasons. First, because when I work on my application, I actually want to work on my application rather than the external things. But there is so many technologies to learn. You need to understand how to install things into Kubernetes. You need to understand what is Helm. You need to understand what other production solutions and tools your team decided to use. There is a complexity of that, and there is also, you want your local development environment, and you want your CI systems to be similar to the production environments, right? Because you want actually things, when you run them locally, you want that to mean something in the grand scheme of things. And that is very, very hard, especially with the more technologies we throw into the soup of our applications. So the typical DevOps lifecycle for software development. As application developers, we are more on the side of the left circle, the inner loop, and there are a number of things which were activities that we need to perform. And we can plan, right? We have all good ideas about how to write our code, and we can even change the code in the ways that is normal, because it's just text, right? Nowadays, even AI can change our code. It's not a problem. The problem is to find where to change the code and to understand in which way you can change the code, and then actually understanding that you didn't break anything else when you changed the code. And this is where we need to run stuff. This is where we need to test stuff, and that becomes complex because we cannot run nowadays. It's really, really hard to run things in isolation. How many of you work on sort of like libraries and stuff? How many of you work on more like application side of things? Almost everyone, right? And to run your applications, you need all the dependencies, you need the environment, and it needs to mean something. And you need to test, and when you change the code, you need to understand that the changes you do, you make to the code, to your application, actually meaningful, and they're good changes, rather than breaking everything. So for that, we need to test. And to test things, we need to run things. And how do we test all of this? Well, there are different ways to organize your tests, but in the systems which are sort of composed from different individual components, I personally believe that integration tests are the way to go. I work at Docker. My name is OLEG ŠELAJEV, and I deal with test containers and developer relations, concentrating on developer productivity. And I joined Docker in the recent acquisition, December acquisition of the startup called Atomic Jar, where we maintained the test containers libraries. So I talked quite a bit to developers about how they test things and the research adjacent technologies, and this is how this session came to be. So our integration tests. It's a sweet spot between the complexity of setting everything up and also the confidence that you get from the test results. If you just test your small pieces of code in isolation, it's great and easy to write, easy to run, easy to maintain. But do you get actually the good information out of the signal? Yeah, when something breaks and when your unit takes a break, when the build is red, you understand something is broken. Very good. Do you get the opposite signal? When your tests pass, do you have the confidence to say, like, yeah, my application works, I can deploy it in production? What's very, very common is if you mostly do unit tests, you do not have that confidence. So integration tests, you can have a high fidelity test suites where you use the technologies that you use in production, and you verify that integration works, that there exists some configuration setups where things actually do work. So there is hope that if you configure them correctly in production, stuff will not break. And they're still easier to maintain and write and use than sort of complex end-to-end tests that run in environments similar to production. There are a number of ways how we can run integration tests. There are sort of the trade-off between the complexity and accuracy and performance. So some people say that, well, no matter what I do, there will be failures in production, right? We cannot avoid all failure. So the best way to get the confidence that stuff works in production is to run it in production. And then just get really, really good at fixing it quickly before anyone notices. But it's also like it's a slippery slope, right? Like for some applications and domains, that could be acceptable. And for some applications and domains and systems, that could be a little bit too close to a failure where there is human lives or even just money on the line. Because, well, could be a lot of money. going a step down, if we don't test in production, we can test against containerized models of technologies that we run in production. If you use your databases, if you use your message brokers, if you use your cloud technologies in production, you can have your integration tests that use the same things, but in a setup that is not really fully production-like, but isolates your application around and kind of sort of models the production environments. You can mock all the services at the service level, and in the end, you can also mock things in your code, which is, well, personally, I would not recommend doing that very much, because changing my application code for testing purposes is just a misguided idea, I think, in the first place. So we're going to concentrate on, in this session, on testing against containerized models of services in for our applications and mocking things at the service level. And for that, we're going to explore two technologies today, test containers and microcs, and how they work together for creating those environments where you can test against, have your tests run with good confidence that in production it will also work. So how do we enable developer experience without sort of getting all the complexity of production for us here? So as developers, we love API. If somebody gives you a library, you can do things with it, right? And you, as a developer, you know the best what you want to achieve, right? And you have the freedom to create things, and only imagination is the limits, limits what you can do. So we are not going to talk about products. We're going to talk about libraries and APIs and tools, which luckily both of those solutions offer. So test containers. How many of you use and love test containers? Very good. How sneakily I added love there. And you're like, yes, yeah. Very good. Approximately half of you. So test containers are open source libraries implemented in different languages, and they give you programmatic API to do things in containers. What it means is that in your code, in your application, probably application lifecycle, or in your tests, you can write a bit of code, and it can spin up containers, and it can configure services in those containers that your application can use there to run. We target pre-production use cases, so most naturally, it's for testing, thus the name, test containers, even though the applications of the libraries go a little bit further. And it gives you approximately the following things. It gives you the configuration of containers and services in containers via API, managing the lifecycle of said services and containers as the API. It gives you the convenience API for getting and wiring services together. Like out of the database container, you can get a JDBC URL, or out of a Kafka container, you can get the Bootstrap servers URL, or getting any like sort of endpoints from other service containers. And it also gives you, being in the code, it also gives you an excellent opportunity to use abstraction, which is, it brings you the whole ecosystem of modules, which are the predefined configurations, how you can run certain technologies via test containers. So as a developer, you don't need to know how to run particular things. You can run technologies with just a few lines of code. There's a whole suite of products around it. There is the open source libraries. There is the cloud software as a service backend. If you don't want to run containers yourself, there is an application called Test Containers Desktop, which simplifies working with test container setups. But it all starts with using the open source libraries, and we're gonna look at that today. So here's a little demo. Here's a little demo. Here is a little demo. Where's my ID? Okay, perfect. So this is my most normal application project. It's a Maven project. I have added my test containers libraries to my POM. And now what I can do, I can get access to my programmatic API to do things in containers. So I can say generic container, and we're going to run Redis, because the Redis is a cool technology. And we're going to say new generic container, and it can run any Docker image that you wish. So for example, we can do Redis. Let's do, come on, constant assist. Let's do Alpine, because it's smaller. So this abstraction now is an object, right? And we can do with it anything that we can do with a Docker container. So we can configure it in any way possible. We can expose ports. We can set up dependencies when we need to run multiple containers. We can overwrite commands for this Docker image. We can overwrite. We can send files into the test container to configure the service. For Redis, the configuration is super, super simple. It starts, it works out of the box. We don't need any configuration. We just need to be able to access this instance of Redis from our application if we wish to work with it. So we expose the port, and the Redis runs on 6379 there. And then with this instance, what we get the lifecycle API. So we can start the container, we can stop the container, and somewhere in the middle we can do, for example, get some information about where our instance of the service is running. So we can do, say, Redis get host plus the colon plus Redis get mapped port for that port that we're exposing. Test containers tries to be a very good library for your integration test. So we try to nudge you into the direction of doing the right thing. So we're trying to make doing the right thing easy and doing the wrong thing hard. So one example of that is if you want to run multiple containers, you can run them. All you need is just a Docker environment. But there is a resource that is not fully parallelizable. This is your host machine on which you're running this. Right? So the ports that you map into containers, they could be the same from each individual container, but on the host machine, they need to be different. Otherwise, there will be collisions. Because if you already bind one port to one container, you cannot use the same number for that. So test containers makes it easy to expose ports with dynamically generated random high-value ports to help you avoid an issue like that. Test containers also, for example, takes care of the cleanup. Even if you don't do that manually, we will take care. We'll stop the containers when your tests stop. Even if your test process crashes or anything, we will clean everything up. So next time you run the tests, you get a new, clean, fresh environment, because we want tests to be repeatable. So this is a small application, very simple. We can run this. What will happen here is we're going to start our application. Test containers will find my Docker environment. It will, if necessary, pull the Redis image, and then it will start that Redis image, and it will print me a URL where that Redis is running. So if I would do that in my application tests, I can then feed that URL to my application and say, here, this is your Redis. And then it will work, and my testing environment becomes isolated and self-contained. I don't depend on any third-party provisioned configuration. And as a developer, I can do whatever I want with this setup, right? Because it's just in the code. If I need my tests to have different slices and different environments for different types of tests, I can do this. If I have a part of the test that tests negative use cases, like what happens when my database schema is broken, right? I can create just a new database for myself, run those tests, break the database, clean it up, and worry not a single second about, like, will my other tests be affected or anything like this. So very simple thing. And then on top of that, there is also the abstractions for test containers modules. So for example, if I need to run Postgres, right, I can just say a new Postgres container and give it a Docker image name, which would be some Postgres Docker image thing. And then this is just, it comes from a library that you can import into your project. And then you don't need to know how to do all this. Right? For Postgres, maybe it's not that bad, but for other technologies, it could be considerable just to configure how to run in containers. So test containers takes all that pain of configuration away from you, and you can do any complex setups. You can create networks, you can connect services together, you can run cloud-native projects in that. You can run tooling in containers if you wish to do so, and you can work with those things as if they are installed locally. And all that is needed is a little bit of code and a Docker environment for us to run containers, which mostly everyone has in some shape or form. And the best part of this, right, besides just being able to run this thing locally without depending on anything, I can also run the same thing in CI. If this would be my test, it would look like a like a unit test, right? I could run it with a little play icon in my IDE, but also my CI will be able to run it. And it will not require any complex setups. I don't need to go and bother my platform team anytime I need to change something in my configuration for the environment. I can just write it in the code, and it will run. And then my CI will become the single source of truth for the quality of the applications, because, well, it will run the tests at all times. And then depending on that, like, you actually need to write your tests yourself. We cannot actually write tests for you, but we can simplify creating the setups. And then you can have high-value, high-level integration tests that run, and your application works with things that you use in production, whether that is a Postgres or Redis or Kafka or anything in between. So if we go to testcontainers.com and then go to modules here, there is a cool thing here. We see there is a bunch of technologies that are supported, and those all come from like either community-managed things. If you want to run a Kubernetes cluster, for example, from your application tests, you don't need to do anything complex. You just run a K3s container, which is K3s is a Kubernetes distribution, and you can just have it right on your machine, and then you can have a repeatable environment like this. And then all the other technologies that you don't need to understand how to run them. And there are different types of technologies, right? There are databases, there are message brokers, there are, for example, cloud emulators. So if you run AWS, you can use local stack for local testing and creating local development environments. Local stack is, of course, the model of AWS technology that you can run locally. And there are also, among the modules, some of them are official modules. This is where the test containers team and the vendor of the technology came to the agreement that this is a great way to do this. And both teams kind of sort of maintain those. One of those official modules is microx, which we're going to talk about in a little bit, which is the technology to transform your API contracts into mocks automatically. So with test containers, it's very, like, usually our applications have three types of dependencies, service dependencies. These are infrastructure dependencies, like a database. These are the cloud technology dependencies, like you need to, like a model of S3 or Dynamo or SQS or something, if you're using AWS, or like a Google Cloud, I don't know, like a Spanner emulator, which is the database, or Cosmos DB on Azure, right? So the cloud technologies, which are hard to test, otherwise we need to rely on using and locally running models. And then the third type of service dependencies that our application depend on is actually like third-party APIs, right? The other applications that our colleagues or even ourselves were developing, or maybe those are the third-party APIs that are provided by, I don't know, vendors, right? You depend on the GitHub API and you have to use it, and you need to somehow test against it, but it's kind of awkward to go and hit actual GitHub every time you need to run a test. So you need to model them somehow. And for that, you need to mock those APIs. And this is where we need to go to this other line where we mock the services, and the best way to do that is to do that on the service level. The idea for the integration test is to be isolated from a large environment. You don't want to run the actual services because they will bring the other services and bring the other services and bring the other services, and eventually you need to run the whole deployment just for your tests, which will be infeasible at a certain point. I think there was a series of articles at Lyft, which is the ride-hauling application, right, about how they did testing. And, well, they tried at some point just to give developers bigger and bigger machines to run the whole deployment because it was easier. But at a certain point, even Lyft couldn't give developers big enough machines because the deployment became so big. So you need to cut your production environment, that picture with different services. You need to cut that somewhere, and the best way to do that is around the immediate dependencies of your app, because then you know when your tests are failing, when your application is failing, it's you who are at fault. Because like you are not using the actual services. You are either mocking the third-party APIs or using the stock technologies. So if something doesn't work, you are at fault, which is great, because if you are at fault, you can fix it. if your testing setup depends on some other application that you containerize and run, well, the actual application, then if those people are doing something dumb and break your build, you cannot fix it because like it's not in your app, it's somebody else's mistake. So we want to mock things, and we do that with microcs. So how do you run microcs? It's a, well, in general, microcs is the CNCF sandbox project, and what they do, they give you tools to ingest. We're going to get to this in a moment, but I just wanted to say, when they give you tools to ingest the definitions of your API and create mocks. And they target, interestingly enough, not just the short-living mocked services that you would use for just individual sort of integration tests like scenarios, but they also target kind of sort of long-lived mocks where you can deploy microcs into like sort of a staging-like environment, and anyone could use that, and anyone would get those mocked responses as a like sort of a deployed service. So for our cases, of course, if we have a tool to run things in containers, right? And we can run anything that runs in containers programmatically, which as developers we love because it gives us full control. So when you have a hammer, everything becomes nails. So when we need to run something like microcs, we will also be running that in containers, and we're going to spin up those containers programmatically because we don't want to install anything locally for the particular application needs, because that's just error prone. And then eventually it will break as well. So everything becomes nails, and then we're going to install microcs. So microcs turns your API contracts into live mocks, and they have the whole set of technologies that you can run for ingestion of the contracts. They support being a CNCF project and being a good open source citizen. They support all kinds of formats for describing your API contract. Most known from here is probably OpenAPI, which is a description of API services for synchronous request response situations. But also, interestingly enough, and we're going to see some examples of that, they also support the async API specs. So when your services talk via a message broker, you can still mock those interactions with microcs, which I think is very, very interesting because more and more services, in my experience, communicate via like Kafka-like scenarios, and it's hard to test that because, well, with a third-party service with that like a synchronous REST-like interface, you understand how to test this. Like you can even write like a one-liner, like Python script or something that would just be a service that spins. You give it requests and it gives you some canned mocked responses. But like with Kafka, it's a little bit harder because there are like topics of the questions of configurations, various topics and so on. So async API, both for synchronous and async API testing, you can use microcs here. So, and then when you also have mocks on which you define tests, right? They're going to use those. You're going to have those contracts, the definition of the test of the API. You're going to use them to generate mocks automatically. And then when you have that part, there is just one step further if you want to go into the contract tests. And contract tests is a very fascinating concept. Is when you have two parties that need to talk to each other, right? When there is always a consumer and a producer in any communication. They might talk through like a message broker or directly, but contract tests allow you to test both parts of the integration there on the consumer side, on the producer side, and get automatic results that will fail if one of the parties is doing something that they didn't communicate properly to the other one. And that is very, very important because the issues there, sometimes the issues are actually bugs and like mistakes that we make. But very often when we talk about issues on the integration border between services, they arise because there was not enough communication between different parties. One team imagined that the service will act like this, but the actual team implementing the service did something else, right? And they didn't talk And that's the problem, because like talking to people is hard. I understand that developers don't very often like talking to people. It's easier to implement something according to your assumptions in your head and then blame everyone else for having different assumptions. So contract tests give you a tool to establish that communication between the teams, right? The consumer part, we're going to use the mocks. The producer part will publish the specification for what their services are doing. The producer side can automatically test whether their services, their implementation actually acts according to this spec, right? Both parts are automatic. You throw it in CI, and you work with it, and then when it breaks, you go and talk to each other. So that removes the biggest hurdle of figuring out when you need to go and talk to other people. It's when the build breaks. And then you go and figure it out. So we're going to see a little example of that. And then with microcs, with test containers, we don't just create those environments for tests, right? Remember, we want the environment parity. We want our CI environment to be as close to production as possible, right? At least using the high fidelity models and real services. And then we want our development environment be as close as possible to our CI environment. Because when something breaks in CI, funny how it happens, you need to fix it in development. Like, there is no other place to fix it. Like, it needs to go back to development, you need to change something, and then it goes back to CI. Like, so to speed up that inner development loop, you need development parity. You need the local setup be as close as possible to CI setup. So with that, we're going to see a bunch of demos for our application, how test containers and microcs work together, and how you can do tests and local development setup based on the combination of these tools. Right, so we're going to talk about the application, and it's a Spring application. It's a simple application, and it's very much like me. It deals, and the product domain of that is pastries, and it consumes pastries, just like me. Love it. And it also sends orders to buy or sell pastries. And of course, to buy or sell a pastry, you need to actually verify whether pastries are well, available, right? And this order service is what we're going to work on, and it needs to work with the pastry service, and it also needs to send the some messages to the billing domain, which is where we're going to see the async API test and communication. And inside that order service, inside of that rectangle, we're going to have, like, it's a Spring application. So it does exactly this. It gets the HTTP endpoint. It has the some business logic for processing and creating the orders, because that's what our consumer on the left side will request. And then we talk to a pastry API using a REST endpoint, and then we talk to, well, sort of the order verification service via Kafka. So we publish messages to Kafka, and we consume messages to Kafka. So this sample application actually shows you all 4 types of communication patterns, right? It requests, it gets requests, REST requests, it sends REST requests, and it also writes and reads from Kafka. So this is what we're going to do. And the first thing that we're going to look at is the REST API test, which is we're gonna see in a second. Right, so here's my Spring application for pastries. It's very, very simple. My pastry is just a record with a name and description. Don't mind the price being double. This is not production level code. That's on purpose, so you don't copy paste it, but understand what it works, what it does. And it's a very, very simple Spring application. It creates the Kafka service that listens to the events, and then it writes messages to Kafka. It's a very, very simple, application, right? And there is a REST controller for the API to do with orders, and it just gets HTTP requests and creates orders, which will verify that pastries exist, and then send some Kafka messages. So how do I work with this application? If I need to run this, can I run this application? If I would just like this application, what do I need to run this application? I need two things, right? I need my Kafka, because I want to send messages to Kafka. And then if I don't have Kafka, my application will not run, because it will be like, I want to send a message to Kafka, but there is no Kafka, so I'm failing, right? So boom, done. And I also need some sort of a pastry service, because when it wants to get some data about pastries, that data needs to come from somewhere, right? And in this case, we need those two dependencies. And we do exactly that. This is a Spring Boot application which has an excellent integration with test containers. So what we can do, we can define our test containers as beans for our Spring application. And for other application frameworks in the Java world, there are similar integrations where test containers is integrated in the lifecycle very, very natively. But Spring is well, sort of. How many of you do Spring? How many of you do something else? OK, decent. Like 1/4 maybe. Very good. We're going to concentrate on Spring for two reasons. Because there were more Spring people in the audience. And also my example is in Spring. So which I knew. Right. So you can expose test containers things as beans. And then the Spring Boot will take care of the lifecycle and initializing those things. And even in some cases, connecting to the services automatically. Which is sort of a new thing since last year. So for my Kafka container configuration, what I will do, I will just add the test containers Kafka library to the class path, to the test class path, and I will just create the Kafka container saying run that Confluent Kafka, and we'll configure the network. So my microx containers that I'm going to run would also be able to connect to my Kafka. And I will do the same for the microx ensemble, which will start actually several containers here. It starts 3 containers. But as an application developer using this, you don't need to know these details. The same way you don't need to know how to run Kafka in a container, because it's actually it's a decently long file. Right? Right. You don't need to know all this. And the same thing, you don't need to know very many things about how to run containers for microx. You just define the images that you need to run. You can get them from any Docker registry, internal Docker registries as well. And then you just configure that. And because this is the beauty, if you didn't think about that before, this is the beauty of the test containers approach. As developers, how many of you love documentation? How many of you actually go and read documentation on a regular basis? So excuse me, let's be honest here. In our experience, things that are described how to do right in documentation are way less, like documentation is way less effective than being in the IDE. If I can make the right thing available with just typing a dot and picking from this list, there are no questions. Developers find it. If the way to do things is actually not here, but described in the documentation that you will find if you go to the website and put in the search box the thing that you're looking for, you will find that page, and it has the explanations. Sufficient explanations, because when people come with questions and we link them to that page, they understand and it resolves the question. They don't find it, which is interesting. So this is the takeaway. If you don't take anything else, reading documentation is a virtue. It will catapult you in the upper echelons of productive engineers. Right? But like the point, sorry, I digress. Right? We can run containers. We can configure them right here. And for microx containers, we're going to do exactly that. We're going to say that, please, this is my Kafka, because we want to test the async API communication eventually. And these are my artifacts, which are exactly the YAML files for OpenAPI. What is the description of the order service? What is the description of the async API for our communication between the publisher? And what are the API for the pastries? So if we look at them, we have this OpenAPI pastries. This is an OpenAPI spec, right? It defines which requests are supported. It also has the examples of values and messages and requests and responses that we're going to use. And this is very, very important. The examples is what Microx uses for running and creating the mocks. So those messages will be, and those responses will be available for us. So we can get pastry by the name, we get pastries. So for example, we can do something like this. We can get that French pastry and this French pastry. Maybe not French, but hopefully, right? So we can get those pastries, but we cannot, for example, get something else. We cannot get like a caramel eclair or something like this. So now, with our containers configured, what we can do, we can run this application. We can run this application. We will need to start the containers, and we'll need to tell the application where those containers are running, which we do exactly this. In the properties files, we can just, or in the properties dynamically, we can just say, oh, look, the pastries URL is actually whatever the container returns to us where the pastries API is running. You don't need to know. You don't actually need to know what is the exact value of that string, because as an application, like as a developer, you never touch it. You know it's a string that points to the pastries API. What exactly is there is not, well, you don't need to know the contents of that. And the same with the Kafka configuration topics. We configure our application to use those for the particular things. And as you saw, which was listener, right? In the listener here, we used the same exact configuration value to get the, well, events reading from Kafka. Right, so with all that, how do you use this configuration for the containers? We create the entry point for our application in our test class path, so we can run it. So we run this application, and it does exactly the same thing as it did with Redis. It finds our Docker environment, and it runs, and it creates the Microx containers. And I'm using the cloud service, which the VM passivated before, so it needs to pull things. Again, cloud to cloud is going to be very, very fast. So in any second, it will just finish initializing those things. Normally, test containers will, of course, use the normal Docker cache, so you don't need to pull images again and again. But it will just figure itself out in a second. And then the application will start, and then you can use it, right? And you can work on this application as if it was working with an actual pastry service, because it has some pastries in the mocked responses. So you can send those. You can also, there is a Kafka, so you can send messages into Kafka. You can manually create the messages to listen to from Kafka. Any application will work as if it runs in a properly configured environment. And the benefits of this, instead of mocking any parts or like cutting out the code that says like, oh, in development, don't send Kafka messages because I don't have Kafka. The benefits are obvious. Well, if you change the code for your development purposes, that's where the bugs will creep in. Right? It's just inevitable. So we do this. It starts. I don't understand why it's so slow, but why is it so slow? We run it. We run it in the cloud 20 milliseconds away, which is lucky you. How many of you are from London? There is a data center right here somewhere. So for using cloud, you are very, very lucky. OK, our Kafka started. Our listeners has started. And then if we do some curl requests, for example, if we query for this French pastry that we did have in the examples, we get that pastry back, and the order has been created. And then if, for example, we make a mistake there, here, right? We should get, wait, no. Right, if we get something else, there are not available eclairs, and then we get a different response. So our application is working. Our application is running, and we can use it properly, right? So now it's time to work with the tests. And with the tests, we want to use what we want to use. We want to use the same setup for environment parity. So we're going to use the same configuration for our containers, and we're going to just use them in the tests, right? So the same Kafka and the same base integration test. So we import the containers configuration, which is a Spring facility to kind of sort of add those beans into our dependency graph of the beans. So Spring Boot will store them and so on. We're going to have the environment for us. And we expose the host ports on our machine to the containers using this idiom. So our containers can access our application as well. And then we're gonna run the tests. And the test can be of any complexity, but this is a basic test for the pastries API. We're gonna just query whether we have some pastries, and we're gonna have some asserts. To run those tests, of course, we need the whole integration setup present, so we can run this, and it will be green because it's a predefined demo. But you get the point, right? You can write tests, and you can write those tests, and you can exercise your application, not in isolation some functions, right? But you can exercise as large chunks of your application as necessary. So here we just query the pastry names and then get the availability status. But you can exercise any larger chunks of code, and it can do some business logic, and you have high-level integration tests where you test actually for business behaviors of your application rather than snippets of code in isolation, whether your application can marshal an entity to a JSON correctly, right? Because that gives you low confidence in the fact that other stuff works. But if you actually hit the, say, like create an order and you verify the whole workflow, you get much higher confidence. So let's go back to the slides very quickly. I'm not going to even not even going to do in the mode. So this is what happened. Our tests asked us to list the pastries, and our client went into the REST client, and the REST client sent the GET request there, and then the microx, which was initialized with our API contract in the beginning of the test lifecycle, responded with a JSON. We got the response. We got the pastries back. Our test verified that the pastries are good. This is the simplest case of mocking a third-party API. And the only thing that you needed for that was the definition of the API, right? Only the open API spec for this. Now, the next one. Can we also do that on the producer side? So if now our application is a producer in the API world, somebody queries for orders, right? Can we write tests like that? And the answer is yes. And semantically, what will happen is that we can feed the OpenAPI spec to a microx instance, and the microx instance will, and also tell where the application is running, right? And the microx instance will go through all the available API calls, and will try to see whether the responses from our application actually conform to the contract that we, well, not the contract, to the spec that we defined with the OpenAPI spec. Interestingly enough, this is just a single test. So if we look at the contract test here, we just define, this is our request, this is what we want to run. We're going to feed you OpenAPI schema. We're going to have the application to test on that URL. So this we need, it's a weird looking URL because we access our application from within the container. And then we just say, like, microx that we created before, test this endpoint, and then we get the test result back. And then we can inspect that whether our producer side of the thing is actually conforming. So can we release this application into the wild and know that whoever uses that actually can use it in a sensible way? Because now with both parts tested, right? If a producer tests against the schema and the consumer tests against mocks generated from the schema, there were way less margins for error between any incompatibilities, right? Because it's all automated. And if something breaks, it means that the schema was maybe evolved incorrectly, or maybe there were some assumptions about how your client, how your consumer part uses the producer. So you run that, you verify the producer API and the consumer API. And out of those two, you can build contract tests. And then the interesting part is the tests for async events. There are two parts of this as well, producer and consumer. So if you want test the publisher, this is what we do, order service and the event publisher. And it's a little bit complicated, but the setup is as follows. We trigger the endpoint for the async event, and then microx, which was initialized, will start pulling the messages from our Kafka service, expecting the messages. And then we generate the test, and we touch our application, expecting it to do something and produce those Kafka messages. And at the end, for the verification, we go to microx and say, like, hi, did you actually receive the messages that we expected you to receive at the end of this interaction? So there is a setup. There is, as in any test, is then invoking production code, and then verification part here. And in the code, it looks exactly like that as well. So this is the order service tests. This application on GitHub, so you can play with it later if you want. We prepare the microx saying that, oh, we're gonna monitor the orders created in the Kafka thing. We prepare the order info that we're gonna use in our application to trigger the production code. We say to microx, oh, listen to the Kafka topics. We place the order with that prepared object, and then we get the test results from microx, and we can ask, did you receive the messages that we expected to receive? So that means we don't need to know how exactly application is handling this, right? We just know when we post the order, the Kafka messages need to go out. So it means if you refactor the application within, this high-level test will not change unless your business requirements change, which is great because you can refactor your application however you want, and you will never break tests when the business logic is still intact. Right. And then the opposite way is as well. It's even a little bit more complex in the schema of things, but the implementation is very simple. We're gonna create the environment, and we're gonna tell microx, start sending those messages that our application expects to consume from the thing. And then in the test, we just wait for the side effects of processing those messages to appear in our application. Right? So the microx will start send messages, and then eventually we're gonna be able to get the orders that were created from those messages in our application and verify that data exists. And on the picture level, looks exactly like that. So if we test the consumer side of events, there is a setup that sort of prepares everything, and our application pulls for messages to update the order status, to save that in the memory store. And then during the test, actually, we do exactly this. We try to find the side effects, and then if the side effects do not appear after a certain timeout, it means something is broken. Unfortunately, that's how it is with the asynchronous events. You cannot know, you can only rely on timeouts, right? Because that's how it is. Right, so all in all, what you can do with the combination of test containers and microx, you can enable your local development experience without recreating the production environments locally, without installing your Kubernetes systems, and without actually running the third-party services, but instead relying on the models of those. And you can have the consistent approach to how you handle and how you manage the life cycle of third-party services that you mock both for REST events, synchronous and async events, your infrastructure-like dependencies like databases and message brokers, and cloud technologies, which covers almost universally all the use cases that your services will need to. And you can have those productive setups where you write tests that work with technologies that are very similar to production, and you can have confidence that if your test suite passes, that actually means that your application of a good quality, and you can throw it all over the wall to the operations team. Just kidding. You can deploy it in production and maintain it yourself in the proper DevOps spirit. Right. We're out of time, so some links. Microx is available at Microx. Test containers is available at Test containers. And the sample application, if you want to run those tests and see the descriptions and see how you can change it to see the tests fail, is available on GitHub and the Microx Test Containers Java Spring demo. If you have more questions, I will try to pack this very slowly before they kick me out. But we also are available at the Docker booth at the expo floor, so come ask questions and talk to us. Thank you very much for coming.